A very good morning to all of you. Welcome to today's class of data structures and algorithm. In the previous classes, we have studied about the queue data structure and the two fundamental operations what we can perform on the queue data structure. The two fundamental operations were inserting an element into the queue and deleting an element from the queue. And we have also seen the different status of the queue whenever you insert an element and delete an element from the queue. And in this class, we'll be studying about implementation of the queue. So to implement any of the data structures, you have to decide first which particular data storage we want to use. That means the storage mechanism you have to decide first, and based on the queues, any of the data structure will be implemented. So we have studied about implementation of stack and linked list, and there we have implemented either by using array or the linked list. Same way, queues can also be implemented by using either array or the linked list. So array involves the fixed memory allocation for the data structure, whereas a linked list involves a dynamic memory allocation. So array is an example for static memory allocation, and linked list is an example for dynamic memory allocation. Now first let us see how to implement the queues by using array. So in the array implementation of the queues, I think probably we have covered this also in the previous class. We have studied, is it covered? I think I stopped at this point, right? Where I stopped? Here in the array implementation. Can someone tell me where I stopped? I think these algorithms are covered or not? Can you tell me whether these algorithms are covered or not in the previous class?
No, sir.
Okay, fine. Okay, I will go through this. Insert operation. So what basically insert operation involves to check whether the particular queue pointer or rear is pointing to the maximum possible bound or not. That means before you insert an element onto the queue, we have to check whether queue is full. We have to check whether queue is full, else we can insert elements onto the queue. So let us look at the procedure or steps for inserting elements onto the queue. So every algorithm will begin with step, that is start, and then I will consider the queue here. For our explanation purpose, I will take it here. Okay, so let us take this as the queue data structure. This is our queue, which has size of 5, or maximum possible size is 5. And whenever this queue is empty, what we will be doing here is front. I will write F for front and R for rear. So they both will be pointing to null in the beginning, or front will be made to point to null in the beginning, or rear can also be made to point to null in the beginning. The assumption what it indicates here is queue is totally empty in the beginning. There are no elements in the queue. That is how we start. We assume that. That means in step 2, what we are considering here is front is pointing to null. In this case, front is pointing to null. That means there are no elements in the queue, and our queue being considered is empty. If that is the case, we go to step 3. If that is the case, we go to step 3. That means if it is true, we go to step 3, else we go to step 6. Now let us go to the first case we study. It is true. That means front is pointing to null. If front is pointing to null, that indicates that front and rear both are pointing to somewhere, they are not actually pointing to the index location of the queue. If that is the true, If this is true, what we do here is, if front is equal to rear, if this is true, 1 second, I can make it still better. I don't have a corresponding tool here. I'll keep it to some appropriate font, and font, I hope that font is visible. Right? Is it visible now, this font? This algorithm I have taken it here. Is it visible? I'm asking whether is this visible or not. This font, whatever I have taken it here.
Yes, sir.
Sir.
Okay, fine. See, earlier front and rear both are pointing here. There is front. Assume this as a front and this as a rear. Both are pointing to here. What steps we have covered? Step 1, step 2. If front is equal to null, so what we have to do is we have to go to step 3. In step 3, what we are doing here is make front and rear point to 0. That means 0th index, starting index of the array. What is starting index of the array? 0. It will start with 0, 1, 2, 3, and 4. Make it to point to this index. That is, make front and rear both equal to point to 0. That means we have to advance now. That means rear and front, they both must be advanced and they must be made to point to 0. That is, rear is pointing to 0 here and front is also pointing to 0. So now we have come to the actual indexing of the queue. That is step 3. If this is true, yes, that means we're trying to insert the very first element, and before that we'll be scanning the element, that is which element you want to insert into the queue. So let us say the input for our algorithm is 10, 20, 30, 40 and 50. This is what we insert. So let us say the first element being inserted is 10. So in that case, what we do here, the name being considered for this queue is queue. We have taken this name in the algorithm, queue. So the queue of front is equal to element. That means whatever the element you want to store, then store that element in the location, in the front index of the queue array. Front index of the queue array. So what is front? Front is 0. So queue of front in this location, store the element. So what is that element? 10 will be stored successfully, or 10 is stored successfully in that location. Next, once you store this, what we'll do here is, after this step, what is step 5? Step 5 is simply go to step 10. Go to step 10 and stop. That means successfully we have inserted first element onto the queue. We have successfully inserted first element onto the queue. That means 10 is inserted successfully. So assume that you want to insert one more element 20 now. You want to insert one more element 20. So again, you should follow this algorithm procedure now. That means what is that? First step, you should check whether front is pointing to null. Front is not pointing to null in this case. That means we'll go to step 6. What's we 3, 4, find, we'll skip. Why? Because they will be used only when you are inserting first element into the queue, whenever queue is empty. Now queue is not empty. That means there are some elements in the queue. Now before you insert, you have to check whether queue is full. How do you check queue is full? Queue is full only when this rear is pointing to max minus 1. What is maximum size of this queue here? Maximum value for this our queue is 5. So what is max minus 1 then? Max minus 1 is equal to 4. Check this, whether rear pointer is equal to max minus 1. Max minus 1 is 4. Rear is what? Rear is 0. That means this is false. If this is true, what happens? The entire queue will be full and we cannot insert the new elements. So what we are checking? Whether queue is full. How do you check? Rear is equal to max minus 1. What is max minus 1? Max minus 1 is 4. Is rear is pointing to 4? No, it is not pointing to 4. When rear is pointing to 4, then the queue is full and we cannot insert the elements. If this is true, what we do? Go to step 7. What is happening in step 7? Display message saying that entire queue is full and we cannot insert the new elements. Else part. This is true in our case. Else part is true. That means there is some space available in the queue. We will go to else part. What else part says? Go to step number 8. In step number 8, what is happening? We will simply increment the rear to the next location, and in that location we store the new element. What we are doing? Simply rear equal to rear plus 1. Advance the rear to the next location. That is rear equal to rear plus 1. Rear is made to point to the next location. Rear is made to point to the next location. Now rear is not pointing here. Okay. Now what is step number 9 says? Just queue of rear equal to element. Whatever element you want to store, that element should be placed in the rear index of queue array. What is the element you are trying to store? 20 we are trying to store. Queue of rear is 1. Queue of 1 is equal to element. Queue of 1 is equal to element. So elements should be stored in the rear position of the queue. So rear is 1. So queue of 1 is equal to 20. So 20 will get stored in this particular location. Then we'll stop. So assume you want to insert one more element. You will call the insert function once again. You will call the insert function once again. And let us say that you want to insert the element called 30. So what is the procedure? First we'll check whether queue is full. Whether front is equal to null, that is not there in our case. Then check step number 6, whether rear is pointing to max minus 1. In this case, rear is not pointing to max minus 1. Rear is pointing to 1. That means there is some space available in the queue. You can insert the element. What is the procedure? Simply make, now you can skip this algorithm. I'll just explain the procedure here. Increment the rear and make it to point to next location. Rear equal to rear plus 1. That is step 8 and 9 we are doing. Rear equal to rear plus 1. I am making rear to point to this location. Once you make rear to point to this location, it must be erased. What is the next step? In this location, you copy the item. What is the step? Step number 9. What it says? Queue of rear equal to element. Queue of rear is 2. Queue of 2 is equal to element. So element is 30. So likewise, we will store 40 and 50. Whenever you are storing 50, rear will be pointing to this location. Same way like how we performed operations with the stack. Now rear is pointing to this location. Now in this particular scenario, if you want to insert one more element, say we have successfully inserted up to here, and assume that you want to insert one more element called 60. You want to insert one more element onto the queue called 60. We'll call the algorithm once again. So check whether front is equal to null, it is false. Then we will go to step 6. In step 6, we check now whether rear is equal to max minus 1. So rear index is 4. What is max minus 1? Max minus 1 is also 4. In that case, we'll go to step 7. What step 7 says? We'll simply display saying that queue is full. Because maximum possible size for the queue was 5 and 5 elements are successfully inserted onto this queue, and you cannot insert new elements onto the queue. It is not possible to insert some more elements onto the queue. So queue is full. So this is how the insert function onto the queue will work. Just we have to advance rear. Before insertion, you have to advance rear, then you insert the element. Now let us see the delete function for this. So delete could be a reverse of this. That means what we'll do, we'll first take time. So let us go to the delete function. So delete operation. What are the steps involved in delete operation? As usual, before you delete an element from to the queue, you should check whether the pointer front is already pointing to null. Because if front is pointing to null, we know that queue is empty. If front is pointing to null, we know that queue is empty, and we cannot delete elements from the queue. If this is not the case, then only we can delete some elements from the queue. Right? So let us assume now. I'll take this algorithm here. Algorithm to delete element from the queue. Right? Okay, I'll take these algorithm steps here. Then I'll assume our queue in the beginning here. Because we are working on delete operation. And this is what is our queue. Let us assume that rear because we have to discuss all the cases 0, 1, 2, 3, 4. So as usual, max is 4. Now let us assume in this scenario where when the queue is empty, where front is pointing, front is obviously pointing to null. So whenever you want to delete an element, what parameters it is taking? It is taking the queue as well as usual the front index and the rear index will be taken for the deletion purpose. So start the algorithm, check this step. If front is equal to null and rear is equal to null, because whenever this queue is empty, they front and rear both will be pointing to null. This will be the scenario when the queue is empty. There are no elements in the queue. So that is the first case what we have to check. If this is the case, we will go to step 3. What step 3 says? Simply display a message saying that the given queue is empty. And we cannot delete the elements from the queue. And simply we'll go to step 10 and stop. That is the procedure if the queue is empty. Now let us assume that there are some elements. We have inserted some elements. That is, let us take our same queue 10, 20, 30, 40 and 50. In this case, front was pointing to 0th index and rear was pointing to the 4th index. Like whatever we have discussed here. The same queue I have taken for the deletion purpose now. Now if you call the delete function once again, so assume that you call the delete function once again. That means you want to delete some elements from the queue. Now check whether front is equal to null. No, in this case front is not null. That means there are some elements in the queue. You can go on deleting the elements. That means what is else part? Else we will go to step number 4 for a deletion purpose. So what is step number 4? Step number 4 says before you delete, it is possible that there is only one element in the queue. It is possible that there is only one element in the queue. That means front is not equal to null and front is equal to rear. That is possible. That means I'll just try to show that scenario here. One second. Let us take only one element in the queue. This is 10. Front is pointing to the same location and rear is also pointing to the same location. Now this is the scenario. This is the scenario which shows that front is not equal to null. Obviously it is true. Front is not equal to null. It is true. And front is equal to rear. What it indicates? There are elements in the queue, but there is only one element in the queue. In this situation, what you do? If you delete this element, what happens? The entire queue becomes empty. There are elements, but there is only one element in the queue. That is, this indicates there are elements in the queue and front is equal to rear. that indicates you have to go to step number 5. What step number 5 says? Just to remove that element from the queue and store it in the index I. Take a variable called I, then q of front. What is q of front? Q of front is 10. So that will be stored. The deleted element will be stored in a variable called I. Then we'll go to step 6. What step 6 says? See, we are talking about only the case now where only one element is there. Where only one element is there. We'll come to this queue later. Where only one element is there in the queue. If that is the case, if you delete the only one element from the queue, what happens to the queue? Queue becomes empty. That's what we are doing in step 6. What we are indicating in step 6, front and rear, make both to point to -1. -1 or null, whatever convention you want, you can use. That is, front is made to -1 and rear is also made to -1. So what it indicates, now the queue becomes empty. There was only one element and we have deleted that element. Then queue becomes empty. And simply go to step 7. Return the deleted element to the caller and go to step 10. What step 10 says? We'll simply stop. We'll simply stop. This was the scenario when there was only one element in the queue. Now let us come to the normal queue, our queue. That means there are more than one elements in the queue and we want to delete those elements. There are more than one elements in the queue and we want to delete those elements. This is not the scenario. So which scenario we have in our hand? We have the scenario that there are more than one element in the queue. Check that condition. What is that condition? I'll erase this. Right? Is front is equal to null? No. Rear is equal to null? No. That is not the case in our case. Is front is not equal to null? Yes, it is true. Front is equal to rear. Step number 4. Is front is equal to rear? No. Both are false. That means there are elements in the queue and we have more than one element in the queue. That means we should go to step 5. No, if it is true, we have to go to step 5. Else part is true in our case. What else part says? There are more than one element in the queue. That means we should go to step 8. What we are doing in step 8? In step 8, we will simply fetch the front element from the queue. That is I equal to q of front. What is q of front? Q of front is 10. Q of front is 10. That means that is obtained, and simply what we do is return the deleted element to the caller. One second. Here in algorithm, one step is missing. You should increment the front plus plus. After deleting, in program it is implemented, but here they have forgot to mention one step. After you delete that, front should be advanced. It should be made to point to the next element. I think simply they are nowhere it is mentioned. That is one mistake in the algorithm here. We'll take q of front. Q of front is what? 10. 10 is copied to variable, and in the next step simply they are deleting, returning the deleted element to the caller. What is deleted element? 10. But once you delete this, front should be advanced to the next location. Front should be advanced to the next location. That means front should be made to point to next location. For our understanding purpose, I will erase this, saying that that element has been deleted from the queue. Now front is pointing to 2. So that part is missing here, but it is present in the program. That part is missing here. Whenever you delete an element from the front end, front should be made to point to the next index. And this way we go on deleting all the elements. What is this normal procedure? For deletion of an element, you have to increment the rear first, then you have to insert the element. After deletion, you have to increment the front. That means for insertion, first you have to increment the rear. For deletion, after deletion, you have to increment the front. That is the procedure. For inserting, first increment rear, then you insert. For inserting, if you want to insert, first increment the rear and there you store the element. For deletion, what you do? For deletion, it is reverse. For deletion, first we delete, then we enhance the front. That is the case. So these two were the steps are procedures for deleting elements from the queue. Now let us see the example program. This implementation, the program will help us to better understand everything now. Let's program CSIA 7.1. Okay. Okay, I hope this font is visible to you for implementation of all the queue operations. Okay, so this is the, let us study the program for implementation of all the queue operations by using array. These are the required header files, and here queue size being assumed is 100. So for that I have to insert 99 elements for explanation purpose. So what let us assume here is the queue size as 5. In the program demonstration I have taken queue size as 5 only. That means queue is declared, it will declare a queue of size 5. Then front equal to -1, rear equal to -1. These are the 0 index values, and what it will do, it will make front and rear both to point to -1, -1. That is what is these three steps are doing. Q is declared and we have initialized the pointers. These are the prototypes for the functions what we use. As usual, what we discussed in the stack, the same example, the main function we have required local variables are there. These options are displayed for the user or the programmer. What is that? 1 for inserting element into the queue, 2 for deleting elements, 3 for display, and 4 for exit. And you will be asked to enter the choice. You have to enter your choice, and choice whatever it can be, either one. If it is one, you want to insert an element, we will take that element and we'll call the insert function. That body of insert, delete, and display I'll be explaining later. First I'll complete the whole main function. We will insert the element. Again, if you want to insert one more element, case 1 will be matching as usual. We will ask user to enter the element which you want to store. Then we'll store that number in the number 1 variable. Then we'll call the insert function once again. We'll go to the definition of insert function and we'll insert the elements. Assume you are calling, you are selecting choice 2. You want to delete an element from the queue. Then simply we'll call the delete function. Delete function is being called. The body of the delete function will be executing. Then deleted element will be returned back to the number 2 or the caller that will be stored in the number 2. Whenever you delete an element, it is possible whether the element gets deleted or element may not be deleted from the queue. In that case, we'll simply if the element is deleted successfully or removed from the queue, that will be displayed here. Else we will not do anything. Or you can give some error message here saying that the element cannot be deleted from the queue. When element will not get deleted, when the queue is empty and you are still trying to delete the element. In that case, the element will not get deleted. Case 3. What case 3 says, you are simply displaying all the elements of the queue. Then display body of the display function will got all the display function. Then case 4, what it says, simply terminate the execution. Default is you are given some invalid choice and you are asking user to enter the proper choice. You are asking user to enter the proper choice. Okay, am I connected till now? Is there any issues? Audio or video visual issues? Shall I continue?
Yes, sir.
Because in these online classes, we should take some acknowledgement time to time, from time to time. right? This is what is, let us study the definition of insert function now. Let us study the definition of insert function. Right, we were having this queue in the beginning. The entire queue was empty in the beginning. Here the name for the queue what they have taken is queue only, entire queue only, queue, and whatever the index values 0 1 2 3 4 were the index values -1, rear was pointing to -1 and front was also pointing to -1. That was the case in the beginning. Now let us say the input for our queue is 10, 20, 30, 40 and 50. You want to insert these 5 elements onto this particular queue. Now assume that element being passed is 10. That means you want to insert first 10 onto the queue. Check whether front is equal to -1. Front is equal to -1 indicates that queue is totally empty. First you should bring these pointers to this index location. If front is equal to -1, it says it is true. In that case, what we do, front and rear both you have to enhance. That is perform front plus 1. What is front plus 1? Front is -1. -1 plus 1 is 0. That 0 will be assigned to rear as well as front. That means assign 0 to rear and that you assign it to front. That means front and rear both are incremented and make them to point to this location. Rear is pointing to 0 and front is also pointing to 0. So both have been incremented now. Front and rear both are pointing to 0. Now we have got the location where we want to insert the new element. Q of front equal to element. That means element is placed in the front index of the queue. Element is placed in the front index of the queue. What is front index now? Front index is 0. What is the element? Element is 10. So Q of front is equal to element. One second. Ideally what we use here is we will take rear pointer to point, but here they have taken front. So that will not make any issue. Why? Because we are inserting the very first element. We are inserting the very first element. If you write here Q of rear equal to element, that is also fine. That is also fine. Okay. We have successfully inserted one element. Now we'll go back to the caller. Assume that you have given choice 1 once again and you want to insert one more element called 20. Assume that you have given choice 1 once again and you want to insert one more element called 20. So element to be inserted is 20. We'll check in this scenario. If front is equal to -1, no, front is not equal to -1. Where front is pointing? Front is pointing to index 0. Index 0. So if front is it equal to point, is it pointing to maximum index? In this case it is 99, but what is our case? 5. Because what is maximum size? Maximum size is 5 and maximum index is 4. So here it is taken in the program. Let us take it as 4 for our explanation purpose, because if you take it, so many insertions we have to do, right? Is rear is equal to 4? No, it is false. Rear is equal to 0. That means if rear is equal to 4, then we say that Q is full. Now in our case Q is not full. That is also false. Else part what we do, last thing is increment the rear and in that location copy the element. That is perform rear equal to rear plus 1. Advance rear to the next location. Advance rear pointer to the next location. Rear has been incremented and then Q of rear equal to element. Element is placed in the rear index of the Q. Q of rear equal to element. What is the element? 20 is placed successfully. You will go back to the caller. Assume that you have given choice 1 once again. We'll check whether front is equal to -1. No. Whether rear is equal to 4. No, it is false. Then simply what we'll do, we will increment the rear and store the next element. Rear equal to rear plus 1. Make rear to point to this location. Make rear to point to this location and in that location write the next element. That is Q of rear equal to element. What is the element we are storing now? 30 we want to store. 30 is stored in the rear index of the Q. Q of rear equal to 30. 30 is stored successfully. Assume you want to store one more element called 40. From the main you have called once again, you want to store 40. Check whether front is equal to -1. No. Whether rear is equal to 4. No. Next, we, as usual, we increment the rear. Rear equal to rear plus 1. Increment the rear and make it to point to next location. Increment the rear and make it to point to next location. In that location, copy the next element. What is the next element? 40. Element 40 is placed in the rear index of Q. Q of rear is what? 40. Similarly, if you want to insert one more element called 50, what is the procedure? Front is not equal to -1, yes. Rear is not equal to 4, it is also false. We will go to else part. What we do in the else? We will simply increment the rear, make it to point to next index. Rear has been incremented. Next, in that location, what we do? We copy the element. What is that? Element is 50. Q of rear is 4. Q of 4 will get the element 50. 50 is 4. We have to check the full condition also. Let us take one more element. So one more element as 60. You want to insert one more element called 60 from the main function. We will call the insert function once again. We'll check these conditions now. Is front is equal to -1? No, it is false. If rear is equal to 6? No. Is rear is equal to 4? Yes, it is true. Because rear is pointing to the index 4. When rear is pointing to the index 4, we say that entire cube is full. We will give you a message saying that cube is full and we cannot insert some more elements. This is how we insert all the elements onto the queue till the queue becomes full. Right? So we have seen the insert function now. We have seen the insert function. Now let us see how the elements are deleted from the queue. How do we delete some elements from the queue? Let us go to the definition of delete function. Yes, this is what is the delete function. Let us see how the elements will get deleted. This is just to check whether queue is empty. This is just to check whether queue is empty. Now let us say that from the main function you have called the delete function. From the main function you have called the delete function. So delete function definition is being called delete. Before you delete, what we have to check? We have to check whether queue is empty. Because if queue is empty, we cannot delete the elements. So when we say queue is empty whenever front and rear both are pointing to -1. I think at that condition I did not tell you. If it is there somewhere here, I can show. Yes, this is the situation. In this situation, what we say, front and rear both are pointing to -1, then queue is empty. That's what we have to check here. So we are checking whether queue is empty in this case. Front and rear both are pointing to -1. No, that is not the case. That means this is the case, queue will be empty. Now in our case it is not the case. There is some place onto the queue. This is false. Front is not equal to -1 and front is equal to 0. This is the case when there is only one element onto the queue, what we have discussed in our algorithm. When this is the situation, front is pointing here and rear is also pointing here, and this is what is our queue. In this situation, what we do? What we do is we will simply take the front element, that is queue of front, take the only n element and assign it to I, then front and rear both you make it to minus. Because when there is only one element, when you delete that element, then there will be no elements onto the queue and we will simply return to the column. That is also not in our case. What is the case? When all the possibilities are over, that means when queue empty is not true, when there is only one element, what we have to do? We have to delete that element and make front and rear to -1. You have to delete that element and make, because once you delete that only an element, front will be -1 and rear will also be -1. In other case, if this is also not true, what you do? There are more than one element. Simply what we do? Queue of front plus plus. That means obtain queue, the front element from the queue, and then advance the front, then return that to the caller. That is queue of front plus plus. What is queue of front? Queue of front is 10. So that 10 will be placed here. That 10 you have to return entirely. What it will give? Queue of front. Front is 0. So queue of 0 is what? 10. That 10 will be returned. Then we advance the front pointer. That means front has to be advanced now. front has to be made to point to the next location. Front has to be made to point to the next location. For our understanding, what I will do, I will assume that it has been deleted. It has been deleted. So assume if you want to delete one more element from the main function, you will call delete once again. We'll check this condition whether front is equal to -1 and rear is equal to -1. No, it is false. Whether is there only one element in the queue? No, this is also false. Else what we do? We take queue of front and return it to the caller. Then we advance the front pointer because it is post increment. What is queue of front? Queue of front is 20. Obtain 20, then you increment the front pointer. Obtain 20, return it to the caller, then you increment the front pointer. So front will be incremented and it will be made to point to next index. Front has been incremented. This is how we go on deleting all the elements from the queue. This is we go on deleting all the elements from the queue. All right. Now let us see the definition of the display. Display is very simple, like how we display all the elements of the array. Before you display, you have to check whether queue is empty. When queue is empty, if front is pointing to -1, queue is empty. This is not in our case. What we do, else part, various elements of the queue are. What we do, we start from the front index. Assume this is the present queue now. Assume this is the present queue. For display function, take I and make it to point to front index. That means we'll make I to point from this location. It is simply like how we display all the array elements. That's it. Make I to point to front index. Check whether I less than or equal to rear. Till this condition is true, we go on displaying all the queue array elements. That means first you display output, what it will be, queue of front. That is queue of 0 is what, 10 you display. Next queue of 1 is what, 20. Queue of 2 is what, 30. Queue of 3 is what, 40. Queue of 4 is what, 50. This is how we display, like how we display normal array elements. These were the fundamental operations of the queue. The queue implementation is exactly similar to the array implementation. Queue implementation is similar to the array implementation. Only thing is you have to exact algorithm has been implemented here. You have to concentrate on the two conditions. Before you insert, you have to check whether queue is full. Before you delete, you have to check whether queue is empty. Only those two conditions you have to take care. Right? I'll give the demonstration. Here queue size is 100. No, I'll take it as 5. That will be easy for the implementation. The program, right? So let us say choice 2 queue is empty. Choice 3 display queue is empty. Choice 1. What choice 1 says? Enter the element to be added to the queue, 10. Again choice 1, enter the element to be added to the queue, 20. Again I'll give choice 1, enter the element to be added to the queue, 30. So 3 elements we have inserted successfully. I'll display it and check. 10, 20, 30. 3 elements are successfully inserted onto the queue. Now let us add one more element. Choice is 1. I'll add 40. Again I'll add one more element. Choice is 1. Element is 50. Now I'll display 5 elements are successfully inserted onto the queue, 10, 20, 30, 40 and 50. Now queue is full, you cannot insert more elements. Let us try what happens. If you try to insert one more element and give the element as 60. 1 second, choice is 1, element is 60. 1 second, choice is 1, element is, enter. No, it has not got changed. I have not saved the program. I have not saved the program, but it has taken earlier build only. Anyhow, okay. What I'll do, if it will show as the full, because I have to rerun the program. Before that, I'll show the other options. What is that? 2 options. Choice 2. Which element will get deleted? 10 will get deleted. Next, if you give choice 2 once again, which element will get deleted now? 20 will get deleted. So let us 3 display it and check. So what are the elements? 30, 40, 50. So when you go on deleting all the elements, 2, popped element is 30. Again choice 2, popped element is 40. Again choice 2, popped element is 50. Again choice 2, popped element is 60. Again choice 2, popped element is 5. Again choice 2, queue is empty. Overflow condition could not be shown. Why? Because I just what I did, I compiled the previous build only. If you recompile it by changing the size and run the program once again, you'll get the exact possible overflow situation. These were the different operations onto the queue. This was a program for implementing queue operations.